All-American 5 radios were basically little table radios that have 5 tubes in them. There are a lot of variants. They can be sometimes called AA6s because they can have extra stages in them. But I'm going to talk about the broad group of All-American 5 tube type radios. And the reason that all came out was radios before probably 1934, 33, somewhere in there, generally had power transformers and were expensive. And what All-American 5 tube radios were basically hot chassis radios that didn't have a power transformer and were built to a price. They were built really as inexpensive radios. So the very first set of tubes that got used in All-American 5 radios all had a 300 milliamp filament current. Understand when you deal with series string tubes, they all have to have the same filament current so they light up properly. The very first set of tubes that got used were basically the three of the tubes came out of car radios because they were 6-volt filaments, the 6A7, the 78, the 75, so that's the converter of the IF and the detector tube. But then for the power output tube, you couldn't use the 6-volt equivalent. It had to be a 25-volt tube, that's the 43. And the rectifier also had to be a 25-volt tube, which is a 25Z5 rectifier. Those are all multi-pin tubes. Filament currents were 36 watts. Because of that, if you add up 6, 6, 6, 25, and 25, you have to waste some power someplace. And that's where Art Bilski's, well, he doesn't have them anymore. The ballast tubes, or sometimes it would be a resistance line cord, you had to burn up the extra voltage, which was actually 15 watts of power was wasted in a resistor someplace. And that was just extra heat. Very quickly after the multi-pin tubes came out, a series of octal tubes were generated, the 6A8, the 6K7, the 6Q7, the 25L6, and the 25Z6, with the single-ended versions, the 6SA7, 6SK7, and the 6SQ7, which you see are the equivalents I've got on the screen there. They don't have grid caps on them. That pretty much was the lineup that was used up until the very late 30s. We then had 150 milliamp filament currents tubes. So all of a sudden, what got developed was they were able to make, actually the development here was actually the 50L6 and 35Z5, 150 milliamp tubes that could do the same thing as the 300 milliamp tubes. And when you did this and you went to the 150 milliamp current tubes, you now lowered the filament current for the whole tube set down to 18 watts, and you weren't wasting 15 watts in a drop-in resistor. So we have the 12A8, the 12K7, the 12Q7 with single-ended versions, the 12SA7, 12SK7, 12SQ7. Then the 50L6 was the power amplifier, although for a very brief time, the 50L6 wasn't available up front, only the 35L6 was available. It had to do with the development of vacuum tubes, that they were able to develop a 50-volt version. When the first radios came out with 35L6s, you did have to waste some current in a resistor to make up the difference, because those don't, with the 35L6 doesn't add up to 120 volts. But quickly the 50L6 did show up. The reason you really want to go to a 50L6, besides also not wasting any power, is you now had enough heater power to generate enough current in the tube so that the tube can use to its maximum efficiency in generating audio output. So after the war, though, we had miniature tubes. The 12BE6, the 12BA6, the 12AV6, and first the 50B5, later replaced with a 50C5, and then a 35W4 rectifier. All of those are equivalent to those octal tubes. And in fact, there were a lot of radios built after the war that had a combination of both in them because they were using up parts from before the war. But I have a little side thing I want to mention here. Why did the 50B5 change to a 50C5? So I put the diagrams up for the two tubes, and you will notice that on a 50B5, the plate was pin 5, and a 50C5, the grid was pin 5. Grid 1 was pin 5. When the plate, pin 5, is next to the heater pin, pin 4, that put the high DC voltage of the plate next to the high voltage of the AC, because that's generally one of the high voltage points in the series string. And UL didn't like that. In a miniature tube, that's too close together. So the 50B5 was phased out with the new rearranged 50C5 that moved the plate to pin 7, so it was far away from the 2 heater pins. So if you ever wondered why the 50B5 went away and a 50C5 came out, that was the reason.
Hey, Bill?
Yeah.
Besides the pinout, is there any specification difference between the two of them?
They're exactly the same.
All right.
But it was strictly an issue of I think it was UL at the time that requested the manufacturers to do that, because it was just, there are too much problems with arc over. So that's one of the reasons that got changed. So just before the end of tube type table radios, several manufacturers, Admiral was one of them who prominently did this. I think Motorola might have done this. Zenith didn't do this. I think RCA did it too. They created 100 milliamp filament current series string tubes, which the 18FX6, the 18FW6, the 18FY6, the 34DG5, and the 36AM3A. And there's a 36AM3B. All that had to do with controlled heater time warm-up. And one of the reasons for the controlled heater time warm-up, these filaments were a lot more fragile, and they learned also you can make tubes last longer if you control the heater warm-up. You probably noticed when you turn some tubes on, they get real bright and then dim down. They're trying to make these tubes last longer. So with 100 milliamp filament current, you only use 12 watts wasted in the filament, trying to make the sets more efficient. But this lineup didn't last very long, as we moved very quickly into solid-state radios. So you don't see a lot of these 18 and 34, 36 volt tubes out there. And you cannot mix them with the 150 milliamp tubes. It will not work. I'm not checked. And I know the 36AM3A, although the filament is tapped on it like a 35W4 and a 35Z5, it's not tapped for a pilot light. It's tapped as a fuse for the rest of the radio. So it's not directly replaceable functionally as a 35W4. And that was my presentation. Do I have any questions?
Yeah, what was the time frame for the 18 volt tubes there?
They started showing up in the early 60s. I actually looked in Bitmans, and I noticed it in some sets from like 62 to 65. So it was toward the tail end of All American 5 radios, but many manufacturers continued to use the 150 milliamp tubes. And you do take a hit here. The 34 DG5 tube really isn't capable of the same audio power that a 50C5 can, but in a table radio, most people didn't really care. It needed to make noise, and it certainly served that purpose. And as my discussions with Tom always come, everything was built to a price, and all this was done for dollars. Don't think somebody was doing something magical here. They were doing it because they were going to save money. I guess I will just tell those who don't know, I worked for Zenith for 20 years, and they would kill for a penny. Any other questions?
Hey, Bill, maybe it's related, maybe not. Why is it that I swear half of my 35Z5s are blown out on one side?
It's very common. A lot of it has to do with the fact that, the one part of the 35Z5 is supposed to be in parallel with the pilot light. And almost all of them were built with a pilot light in them.
Right.
And if the pilot light blows and you continue to use the radio, you actually put stress on that section, because they also, typically in that radio, if you look at the schematics, they connect the B+ through that too. That's why it shows up bright, dims down, and then brightens up as the set starts to draw current, because it starts to draw B+ current through that section of the 35Z5 and the pilot light. But it needs both of those parts together to run correctly. And people don't replace pilot lights. You probably know that. But that's generally what the issue was.
As the moderator, I'm gonna just interject here and say thank you very much for that great presentation, Bill. That was informative, and boy, you must have practiced it, because it ended right at 10 minutes and the questions went another minute. So, no, that's very informative. And we, again, in the interest of keeping all the presentations moving along, we're going to move to the next one, but stick around at the end. We can talk more about it and ask more questions about Bill's presentation. So Tom, would you like to start and do your presentation next?
Yep. All right. This is actually a former Art Bilski radio that was in a bushel basket. And very unusual set. We'll start right there. There it is. This is made in England by a company called EMOR, and they only made this format radio and seemed to go poof. They kind of were around in the 1946 to maybe 1950 timeframe. So it's an aluminum two-sphere arrangement with a dial band in the middle. And I believe the base on this one is off of an old lamp because it doesn't match any of the other pictures. And then
And weighs a ton.
I'm sorry?
And weighs a ton.
Oh my God. Yeah, it does weigh less than the Westinghouse grandmother clock radio. So there's the top, and that's the speaker grill, but the speaker is not centered on the grill. The speaker is actually mounted on the chassis, and it's offset to one side. But that's a piece of casting. And so you tune it by rotating the globe or this ring on the top arrow. And then you can change bands in the middle, AM and shortwave in the US, AM, shortwave, and long wave in the UK. And then the volume controls here, and then this thumb screw allows you to raise it and lower it from 3.5 feet to 5 feet. There's a close-up of the dial, and it's a cellulose kind of a dial. These little metal straps actually hold the top to the bottom and hold the dial in place. There's the branding, and you can see what their registration numbers are for their design and for other patentable bits. I didn't look up the design patents, but I did look up the main patent, which will come up in a minute. So this is out of the rider manual. There's 2 pages in riders on this thing on the volume 16, which is 1946. And you'll notice even their diagram on the left doesn't match the reality on the right for the base. So obviously they were working through what they wanted to do. And then here's Bill's All-American 5 circuit. And it doesn't make any difference whether it's the UK version or the US version. It has American tubes in it. Because keep in mind, there was a boatload of US tubes in England after World War II. We're servicing all the equipment that we shipped over there. And so nothing particularly special about this. It's plain vanilla, although it does have a power transformer, which is unusual, and it has a 5Y3 instead of having a 35Z5 and a 6V6 instead of having a 50L6. But it's the same basic circuit. It's just they probably have a power transformer in it because they had to have in the UK for the 240 volts. And in fact, I saw a picture online of one that was 240, and it actually was strappable for 120 and so on. This one's just a fixed voltage. So here's the patent, and you'll notice again the base is a 2-layer or 3-layer, depending on your point of view. I read on one thing online that it was cast aluminum. The second page of the patent is interesting because notice they made a literal table radio in the lower left-hand corner on this picture, if you can see my mouse going around. Now again, in the UK, apparently they made a table radio that sat on top of the table as like a miniature pedestal device. I've got a bunch of links in this presentation, so if we find a way to share presentations later, you guys can dig a little further. So there's a guy from Poland named Michel who did this whole thing. His whole deal with his patent is he wanted to make a radio that didn't have knobs on it, and it has a conventional radio. And then they licensed an outfit called Faust in Canada to make these things. So the Canadian version is a little different, the UK version is a little different, and there's other variations. And let's see, oops, sorry. And then that pretty well covers it. There's very little information on this radio, no matter where you look. In fact, some people usually just are quoting the patent. And obviously the UK patent was the primary one. The US patent was basically a duplicate of it. So here's my premise. You know, if this radio, again, notice a different version of it again, and this one's chrome plated. They painted them or they chrome plated them. The aluminum on mine is probably because the paint came off. And the power in the antenna came out the base and laid on the floor, because obviously being all metal, the antenna is not going to work too good. So I'm guessing that what happened is the Russians looked at this and said, well, Sputnik needs to be around, so we'll just do that. And then obviously Star Wars, you know, so that's you know, I think that's the progression. I think that makes sense. And so there you are. I can show you live the actual radio. So here's the radio. You notice you turn this to tune it.
So Tom, are there ventilation holes for the circuitry?
No, I think it just made the aluminum hot, except for the grill on the top. Those are the only holes in it. And
They missed an opportunity by not putting an ashtray in it.
Tom, how does it play? Because I never, you know, like I said, I never got a chance to fix that one.
I didn't fix it. When I got it in a bushel basket, I just put it together so I wouldn't lose the parts. And as you know, this thing is not made to be serviced. And in fact, all this concentric apparatus in the middle for the volume control and the band switch, if you have to dig into that, that's going to be more interesting than even getting the chassis out to fix it. But what happens is you end up kind of supporting it by this lower globe for a while, and there's a lot of stuff hanging in free space until you get the chassis physically out. And looking online, the UK version of this didn't have these straps. What they did is this lid just sat on top. And so if you had to service the tubes, just lifted the lid off, and the speaker was attached to the top center. And some of these you'll see are kind of egg-shaped instead of round. So I'm guessing there's a handful of variants on these things. So it's kind of a, you know, it's a bit of a mystery radio in some ways, but it needs this thing. The other problem is if you ever had aluminum cookware from like the 50s and 60s, that really soft stuff you stare at and it's got a dent in it, this is the same way. This thing's got a million little dings in it. And a guy online has a video on YouTube, and he went to a body shop and had them, you know, do the old Bondo job and sanding to get the thing round again. And I think you'd almost have to do that. And this dial, as you probably can't see, but it's cracked in about 2 or 3 places. It's in good shape otherwise. There is a reproduction of the UK version of this band out there, but unfortunately, or dial, you know, all these guys are doing this stuff are all in their 80s and they're getting out of the business or passing away. So I sent them, both people that do this stuff, an email and said, hey, would you make me a dial, and got nothing. So, you know, we're going to have to find ways to pick up some of these services. You know, as you guys know, Radio Days is pretty much gone. And again, it's all health issues of the principals. So that's what I got. Back to you, Tom, I guess.
Tom, where's the sound port? Where's the speaker port on there?
It's on the top. That grill I showed you on the top in that second slide. It's too heavy to kind of pick up, but maybe you can.
Oh, yeah. Yeah.
There you go.
Nice.
And that's a die casting that's bolted in. So it's about 3/15 of an inch thick.
That's great.
You mentioned that it had a transformer. I assume that's because it's an all metal case.
Well, that would make sense. And also considering it was designed in England where they designed radios with transformers automatically, you know, the Bill's All-American 5 works on 120 volts. They didn't come up with an equivalent string of tubes to run on 240 volts. So, and it's interesting now that we have all this internet access. There's a guy in Australia that Bill and I watch on YouTube. And, you know, he's got all these All-American 5 radios with a transformer on the front end of them because they took the same circuits and the same tubes, but they had to run them on 240 volts.
Oh, that's great. That was 9 minutes and 30 seconds, Tom.
Nice to see it back together.
Thank you.
That's
Hopefully someday we'll have it and I can demonstrate it.
Well, that's great. Thanks very much, Tom. That was very interesting. We'll move on to the next presentation. Who has a presentation? I've got one, and that may be the last formal presentation, but I would ask that some of you guys with all the radios in the background do a little stand-up talk on some of your stuff after I finish mine, if that's okay. So
I'll do that next time because I'll have to do it on my iPad because the laptop, because it's hardwired in, if I unplug it from the cable, I'll lose connection and it's just not convenient.
Well, you can grab a radio and hold it in front of you, Art, if you
Yeah,
want.
just
Hey, I've moved these things enough. I don't want to move them again.
yeah. If you're so inclined, please pitch in with a presentation if you'd like.
I have a brief presentation.
Who is that speaking?
Larry Stark.
Okay, Larry, why don't you just go right ahead?
My presentation is nowhere near professional. I'll have to move my camera here to view some of the radios. But my interest in radio started in the mid-50s with an old All-America 5 radio that I pulled out of a cabinet, and mainly because the cabinet was so large and I wanted something I could put on my bench. So I just had the guts sitting on the table, and I started making some modifications to the oscillator so I could receive ham radio transmissions on the 160 meter band. And that's kind of how I got interested in radio and in shortwave and ultimately into ham radio. My first store-bought ham radio I have here on the table. It's I can move my camera around here. Is an All-America 5 design. It's a Hallicrafters S38E. And it was a great receiver. I can remember during the sunspot cycle high in 1959, with this little radio, I was able to receive ham stations from all over the world, including Asia and Southeast Asia, Southern Asia, with only a simple wire antenna on the 10 meter band 24 hours a day. So it was a real thrill being able to receive those stations. And that's what kind of got me hooked on ham radio. I did make a modification to the S38E. I did modify it for safety, you know, so the chassis would not be hot. And it had a very positive side effect in that it reduced the overall hum that's inherent in many All-America 5 circuits. The use of a polarized line cord and changing the switching from the ground or common line to the normal line made all the difference in the world. Then I was able to ground the direct ground to the chassis for the volume potentiometer, and that's what took away any remnants of hum in that circuit. So if you have All-America 5s and want to make that modification, it's well worth the time. It took me all of about 15 minutes to make that mod. Another thing I wanted to show here is my most recent restoration project. Let's see if I can get the camera in position here. This is a 1945 model National HRO5 receiver, and it uses the plug-in coils. You can see the rectangular shape there in the bottom of the front panel. That's one of the coil units. And I have all the original coil units that went with that particular chassis. They all have a common serial number. And I have some additional coils too, including broadcast band. And I've been doing some broadcast band DXing with it and have really had a lot of fun with that. The other item that I have restored that I can't get the camera to right now is a Hallicrafter SX25 that's been completely recapped restored and realigned. And that's also working very fine. So that's it. I don't have much more here. If anybody has any questions, I'll be glad to answer. Thank you. Thank you, Tom.
Hey, Larry?
Yeah.
I didn't catch the mod you made on the volume control on the Hallicrafters.
Yes. The mod was just to basically change the switching from the cold side of the AC line to the hot side. And matter of fact, I just went online and I Googled All America 5 modifications or something like that. And I found the basic mod circuit. And like I said, it took about 10 minutes. And boy, it really made a difference on the quality of the audio coming out. You know how the All America 5s always have just a slight amount of hum in there. And it took that hum away completely.
You said something about a ground, though, around the volume control.
Yeah, the one of the terminals on the volume control goes to a ground, but not a direct ground according to the original All America 5 circuit. And by making this mod, I was able to take that lead connection and reroute it directly to the chassis, which is at ground potential because of the polarized line cord. And that's what reduced the hum.
Okay, very good. Thank you.
Any other questions? Thank you, Tom.
Thank you, Larry. That was very good. And, you know, I encourage presentations like that where you're sitting next to a radio and you just want to talk to it. I think that's what this is all about. So what we'll do next is we'll put up my presentation. Okay, I'm going to talk to this Midland battery set that I restored a while back and only recently built a battery eliminator for it. So originally I got this in an antique store, and it's an interesting radio from the standpoint of it was made in a small town in Iowa called Decorah, Iowa, which I didn't really have any clue where that place was. I had to look it up. And it was a very short-lived company that made radios in this small town in northeastern Iowa, which today is only got 10,000 people. And it's had 5 companies in its history, which I thought was pretty amazing. I looked at on the website of the Iowa Radio Club, and they've got an excellent reference there that I put in the back of this presentation. But they talk about all the towns in Iowa and what kind of radios were made there. So, but anyway, this was interesting to me because it was the first time I restored a 32-volt set, and so I like that a lot because I've never done such a thing. And it's got 6 tubes and consumes a lot of power in my book, not 19 watts for a battery set. You know, most of the battery sets I had been working with were the portables that you carried around that, you know, had small miniature tubes in them. So the other interesting thing about it is it uses slug tuning instead of a variable capacitance. I'll show us a picture of that later. And it's unusual from the standpoint of the knobs on the left side of the radio. All the radios I've got in my collection, the knobs are either kind of symmetric, or if they're clustered together, they're on the right side of the radio. So it's kind of an unusual thing. If you look at your radios, you'll find that you won't have one with this kind of asymmetry. And it's just a simple case, and the dial bezel is pretty attractive. This one holds the title of the most rodent-infested radio in my collection. it was amazing when I opened up the back. I probably wouldn't have bought it if I seen this, but I think the mice had put an entire couch stuffing inside of it. And there's a lot of work. There's a lot of corrosion due to the mice droppings, and a couple of the tube sockets. When I pushed on the tubes, the sockets just kind of fell into the radio because the rivets had corroded away. So, I mean, if there's any good news here, the mice were comfortable and they didn't eat the speaker cone. So that was, so you can see the kind of crap that was in there. And you can see the tops of the tubes there. They're just coated with this stuff, and you can kind of see where the metal had kind of rusted due to that. I did a wood refinishing job on it. The original finish was very brittle, as you know, radios of this age can be that way. And I don't like to use strippers as much, so if I have a flat surface veneer radio, I usually will scrape it away, and then I, you know, follow it up with some sandpaper, and then I put some coats of clear lacquer and sanded between the coats, and then I had some toning lacquer to kind of finish up and make it look a little nicer. And then it ended up looking pretty nice in my book, and it's got a cool looking dial, and you can see that the dial has got some really cool detail on it for a simple radio. It's pretty neat. And then here's a picture of the slug tuning on the left side of the chassis. This is after I cleaned it up, and you can still see there's a lot of pitted metal around on the chassis, but you can see the slugs that are pulled in and out of those cans, and there's kind of a cam on the front behind the dial that lifts that arm on the left side and pulls the slugs in and out.
I had a question. How do you clean the rust off?
Well, I used this just a real strong cleaner called Super Clean. I didn't try any of these fancy like naval jelly or anything like that, and it removes the rust, but it still leaves the metal in a pitted looking state. So it's not like I could make it look shiny silver again. But I use this stuff called Super Clean.
Thank you.
And I didn't recap it. So, I mean, a lot of times I usually just jump into a radio and recap it, but this, you know, it worked, and it's kind of, I think those are the original parts that were in it, so I just decided to leave it that way. And
Since the B plus isn't above 32 volts, the caps aren't under much stress.
that's a good point, Bill. I like that analysis. And so here's the schematic, and you can kind of see how they wired the filaments on here. It's they wired 5 of the 6 tubes in series, the filaments in series across the 32 volts, and then the output tube, the 25L6, they put in series with a 25 ohm resistor. And so this, that's how they did it, and they ran the plates right off of 32 volts. So you know,
That's 600 milliamps just to light up the filaments. 300 milliamps for each string.
yeah, it's a lot of power. It just seemed like to run something off a battery, it just seemed like the wrong approach. But I guess that's what they did back then after the war. And
I always thought the 32 volt systems were wind turbines or something, some sort of generator that charged up the batteries on a farm.
mm-hmm. Yeah, I don't know much about that. I know Matt had made some comments to me earlier about how they would use wind turbines or things, and then they would have these battery banks of lead acid batteries that they could use to power things like this.
Right. There was Delco had a generators, gasoline generator engine with a control system on it to automatically recharge a bank of lead acid batteries. You could also be recharged by a windmill, and the farm power had a whole 32 volt distribution system with the bizarre situation that all of the plugs were the same as standard Edison and lamp and socket plugs that we use now. So all this 32 volt stuff has typically been plugged into 110. But the notion at the time was that you could start with your own local generator, and then when the power came out to the farm, you could not have to rewire the whole farm. You could just connect it back up to the grid.
Of course, this 32 volt radio would just blow up if you plugged it into 110 volts.
Yeah, a whole suite of household 32 volt appliances would blow up if you plugged it.
Yeah.
Yep.
Oh, thanks for that, Matt. That's a good piece of information. I built a power supply, and there was a nice little spot on the right side there, and I decided to go and design up a 32 volt DC. You know, I'd been running it off of a bench power supply, which it was kind of maxed out, but I figured I'm just going to go do this, and so that's what it looked like. It puts out 32 volts DC and puts out maybe about 700 milliamps, which is just enough to do this. That's my timer. 10 minutes is up. So as a moderator, I get to keep talking. And so I used a solid state voltage regulator, and I bought a Hammond transformer and it's just a full wave rectifier, and then a solid state regulator, and a good heat sink. And then that's the schematic of it, and it works really well. And so here's my references. I found a guy here that had one of these radios, and he has a little picture of it on his website. And then I went to the Iowa Antique Radio Club and Historical Society, and they had a real excellent page on all the radio manufacturers that had been in Iowa. And what I thought was pretty amazing is that there were, as I mentioned earlier, there were actually 5 unique different manufacturers. You can see that this guy just changed the name from El Tatro to Tatro. But for a small town of 10,000 people or whatever, it's had a lot of history. So anyway, that's my presentation.
It's a nice radio you got, Tom. I actually did the AC version of it last year.
Oh, really?
Yeah, exactly the same, other than 32 volt. And I'm surprised they were doing 32 volt that late. I always thought that ended in the mid-30s somewhere, because I did a Delco 32 volt DC, and I found I had to run a 3-prong cord on it with a ground, otherwise it would buzz like crazy.
Nope, there's still a lot of farms in Iowa.
Yeah, I guess they had a lot of farms that maybe weren't right on the grid or something.
Yeah. Interesting.
Any other questions for Tom?
Okay, well, let's see. Do we have any other presentations that people would like to?
While we're thinking about presentations, I think I know the answer to this, but here's a quick poll. How many of our participants restore your own radios? And do you do the cabinets, the chassis, or both?
As long as we're waiting for the poll to come up, another way to get rid of the rust that doesn't cost a lot is go to Target or Menards, and they sell citric acid in a powder form that is used for canning. And you mix some of that with water, and you can immerse parts in it, and it will take the rust off.
Oh,
It's dirt cheap.
thank you, Tom.
All right, thanks.
I haven't tried dabbing it on, because that would be more of what Tom would have needed to do. But I guess if you saturated a rag with it and laid the rag over a portion of it, it probably would work. I've used it very successfully with rusty erector set parts. And again, it takes the rust off. The other thing is, as soon as you get done with it, the thing will tend to flash rust. So you're going to want to put some wax on it or a little bit of oil or something. And so the steps would be as what Tom did. You want to physically clean it with some kind of detergent and whatever, and get all the dirt off, and then do the derusting, and then put something on it to keep it from rusting again.
Gotcha, gotcha.
I
What's
know
that
some
product?
people get some really nasty chassis, strip them, and then have them replated or painted. That's a lot more work. Sorry, somebody was talking. I
Yeah,
interrupted.
what's the name of the product?
Let me Google and see if I can come up with it. And I'll give me a minute to do that. It's made by Ball, the people that do canning products, and it comes in a jar that's about, I don't know, maybe 3-4 inches tall and a couple inches wide.
A cadmium plated chassis, is it okay to do that to it?
It might take the CAD plating off.
That's not good.
Well, you know, if the CAD plating is robust, you're fine. The thing is, you don't want to leave anything in there for days because, you know, basically you're putting it in a low level acid bath. I've had stuff in for, you know, an hour to a few hours. You know, basically I go in and spot check it once in a while. And the other thing is you want to fully immerse whatever it is, because if you have a little portion of it sticking out and you try and get a uniform color by sticking the other end in, you'll never get it.
Thank you, Tom.
All right, it's called Ball Fresh Fruit Produce Protector. And it comes in a 14.8 ounce container. It's green with a label on it with some fruit and the word Ball. $3.69 at Target. That's your total investment, not counting a plastic pan and some water. And I don't have any magic ratio. I just poured a little bit in and mixed it up. I'm sure the more you put in, the more aggressive it's going to be, and then there's probably some point of no return. The other thing is it keeps. I keep it covered, and until it gets so saturated with rust and dirt and junk, it keeps working. And the good news is, being citric acid, you can just put it down the sink, just rinse the container out. Sometimes, you know, one of the things that's worth doing is to have a little brush or a rag, because something may look more rusty than it is because the oxide laid on top of the piece. And if you give it a little bit of brush, it comes right off. Yeah, there's a commercial product called Evapo Rust, which you can buy at almost any home center, which works probably a little more aggressively, but it costs money. This you can go. I've only used a little bit out of this container, and I still have most of the container left.
I also understand Evapo Rust is not actually acidic. It's a different method that doesn't eat the metal and won't cause pitting.
They tell you, though, not to leave it in there, I believe. I've used Evapo Rust, and it's a very effective product. So I think all these things, chemistry is chemistry, and you need to rinse it off in water no matter what you're doing afterwards. That's true of the citric acid thing. You know, the step 2 after you pull it out of the mixture is to rinse it out with water and dry it off real well, and then go from there. And so, okay, I'm beating this to death.
Okay, well, I think we've consumed an hour with some presentations. That was very informative. I'm glad we had a chance to do this. Now, we got a lot of time, so if anybody wants to bring another radio to their camera and talk about it, or have another conversation about something that's of interest to you, let's use the time.